Imagine you're a defense minister. It's 2:41 in the morning. Your phone lights up. Then every phone in the building lights up. Radar operators are shouting numbers your system was never supposed to see. Hundreds, then hundreds more incoming. Your country has some of the most sophisticated missile defense technology on the planet. Billions of dollars, decades of development, international backing. And in the next 90 minutes, you're about to watch the core assumption behind all of it fall apart. This is not a hypothetical. This is a strategic blueprint that has now been proven in live conditions, and every military planner watching it unfold knows exactly what it means for the next decade of global conflict. Here's the question nobody is asking loudly enough. What actually defeats a missile defense system? Most people assume the answer is a better missile, a faster one, a stealthier one, something technologically superior. But what if the answer isn't better? What if the answer is simply more? That's what Iran demonstrated, not through technological breakthrough, but through what military strategists call saturation logic. And once you understand how saturation logic works, you'll understand something uncomfortable. The most expensive defense systems in the world have a ceiling, a limit, a breaking point. And that limit is not determined by how sophisticated the interceptor is. It's determined by math. In this video, I'm going to walk you through exactly what happened, why it worked, what it revealed about modern deterrence, and what the world's most powerful militaries are now scrambling to figure out in response. Let's break it down. To understand why this event was strategically historic, start with scale. During the entire 1991 Gulf War, Iraq launched around 88 Scud ballistic missiles over the course of weeks. Those strikes generated global headlines. They triggered Patriot battery deployments across the region. They shaped air defense doctrine for a generation. Now consider, Iran reportedly launched somewhere between 300 and 1,800 missiles, depending on the source, in a single coordinated overnight operation. Even the conservative figures represent a magnitude of strike density never previously executed in recorded military history against a defended target. But the number itself isn't the story. The structure of the operation is the story. Because Iran didn't just fire a lot of missiles, it fired them in deliberate sequential waves, each designed to attack a different layer of the defensive system. The first wave consisted of older, slower, more predictable ballistic missiles, easy to track, easy to engage. They were designed to be engaged. Their purpose was to force Israeli radar operators to illuminate their full sensor architecture, activate every available battery, and begin burning through interceptor stockpiles against a wave that wasn't carrying the primary payload. Think about what that means operationally. You're using your most advanced and most expensive defensive assets to shoot down missiles whose primary job was never to hit anything important. Their job was to drain you. The second wave arrived while defensive operators were still processing the first. These were solid fuel mobile missiles, far harder to preemptively destroy because they require almost no preparation time to launch. Some reportedly carried maneuvering warheads. In the terminal phase of descent, the warhead can shift its trajectory. An interceptor missile launched to meet it at a calculated intercept point suddenly has no target at that point. The kill probability collapses. The later waves targeted infrastructure, power generation, military logistics nodes, and, critically, air defense batteries that were already depleted from the earlier wave. This is not improvised. This is the product of decades of study, investment, and deliberate reverse engineering of how layered missile defense systems actually function under sustained pressure. Here's the core vulnerability of every air defense system ever built, and why no amount of money fully resolves it. Every system operates on a ratio. Interceptors available versus incoming threat. And interceptors have two critical constraints that the offensive side does not share equally. First, cost asymmetry. A modern air defense interceptor, like those used in Arrow 3 or Patriot systems, costs anywhere from $1 million to $4 million per missile. The ballistic missiles being fired at it can cost anywhere from $20,000 to a few $100,000 depending on sophistication. When you fire 10 missiles that cost $50,000 each, and your adversary burns 2 interceptors at $3 million each to stop them, you spent $500,000 and forced your adversary to spend $6 million. You did not win the engagement in the traditional sense, but you won the economics of the engagement decisively. Second, production rate asymmetry. Interceptors take months to manufacture. Some of the most advanced systems require specialized components, controlled materials, lengthy testing cycles. You cannot replace a depleted battery overnight. You cannot order more the way you'd restock a warehouse. Offensive missiles, by contrast, especially lower-tier ballistic missiles, can be produced at scale far more rapidly and at far lower per-unit cost. So when an adversary coordinates a large volume strike, they're not just trying to overwhelm you today. They're trying to put you in a position where your defense stockpile recovery timeline creates a strategic window of vulnerability that stretches months into the future. That's the math problem, and it doesn't have a clean solution within current kinetic defense architecture. Let's be precise about what Israel's defense network is and isn't. Iron Dome is genuinely one of the most successful short-range defense systems ever deployed. In the context it was designed for, defending against unguided rockets and shorter-range projectiles, it has achieved intercept rates that defense engineers once thought weren't possible at scale. That's real, and it deserves acknowledgement. But Iron Dome was never engineered for 1,000-plus ballistic missiles arriving in sequential waves over 90 minutes. Neither was Arrow 2, Arrow 3, or David's Sling in the combined configuration that was actually fielded that night. No system on Earth was designed for that scenario. That's not a failure of Israeli engineering. That's a structural ceiling built into every kinetic defense architecture currently in service. Official Israeli figures cited intercept rates above 70%. Independent analysis from commercial satellite imagery, flight tracking anomalies, and seismic monitoring records a more complicated picture, with impact evidence at multiple significant locations, including military airfields, logistics infrastructure, and power distribution nodes. Regardless of the exact intercept figure, the strategic demonstration was complete. A coordinated ballistic missile saturation campaign at sufficient scale can exhaust the most layered air defense network currently deployed by any nation on Earth. That statement is now no longer theoretical. Here's where the implications extend beyond the immediate conflict. When U.S. Central Command was monitoring the strike in real time, the question arose inside multiple command centers. If this saturation logic works against Israel's defense network, what does it mean for American naval assets operating within range of similar Iranian capability? Iran has spent years developing and deploying anti-ship ballistic missiles, weapons specifically designed to target large naval vessels at sea. The DF-21D class concept and Iran's own Khalij Fars family of missiles are engineered around the same saturation principle applied to maritime targets. Overwhelm an Aegis-equipped strike group's defensive capacity with enough simultaneous inbounds that the kill chain cannot process them all. Reports from the period described U.S. Navy surface combatants repositioning further from the Strait of Hormuz into open ocean, putting more distance between the fleet and the Iranian coastline, where mobile anti-ship missile launchers were pre-positioned. The Pentagon framed this publicly as routine operational flexibility, but from a deterrence standpoint, the message it sent to every government watching was impossible to ignore. For 70 years, the forward positioning of American carrier strike groups in contested waters has been the most tangible physical expression of U.S. security commitments in the region. When that forward posture becomes tactically uncomfortable, when the cost-benefit calculation of maintaining it inside a specific threat envelope starts to shift, the deterrence value that depended on unconditional forward presence starts to shift with it. Allies noticed, adversaries noticed. The gap between the posture and the press statement told a story that no official briefing could close. The most significant audience watching all of this unfold was not in the Middle East. China's anti-access area denial strategy, the doctrine built around preventing U.S. military power projection into the Western Pacific, is architecturally identical to what Iran executed in this operation. Overwhelm sophisticated American carrier defenses with enough simultaneous inbounds that the Aegis kill chain cannot process them all. Make the cost of sustained forward naval presence inside the first island chain prohibitively high, not by destroying the fleet in a single engagement, but by making every operation operational commander calculate whether remaining inside that threat envelope is worth the risk. Chinese military planners have been wargaming this exact scenario against American carrier groups in the Taiwan Strait for years. What happened in the Persian Gulf wasn't inspiration for them. It was validation of their existing doctrine, a live-fire proof of concept for saturation logic against a defended, capable, well-resourced adversary. Every classified simulation running in Beijing, Washington, Moscow, and Brussels was updated in the weeks following this event. Every alliance built on the assumption that American technological superiority remains an unqualified deterrent force received a dataset it is still processing.
So where does this leave global defense planning? 3 shifts are already underway, and they will define military investment for the next decade. Directed energy. Laser-based intercept systems don't have a magazine. They don't run out of interceptors. They fire at the speed of light and at a marginal cost per engagement that is a fraction of kinetic interceptors. The technological barriers to deploying them at operational scale are real, but no longer speculative. What this event did was collapse the timeline from long-term aspiration to urgent operational requirement. Multiple programs already in advanced development are now receiving priority funding and accelerated testing cycles. Autonomous swarm defense. AI-driven sensor fusion that can process hundreds of simultaneous inbound tracks faster than human operators, identifying, prioritizing, and allocating intercept resources across a distributed battery network without the decision latency of a human command chain. This is not science fiction. It's in active development and active testing. The timeline just got shorter. Offensive saturation as standard doctrine. The flip side of this event is that every mid-tier power watching has now seen a validated blueprint for how to pressure a technologically superior adversary. Volume, coordination, economic sustainability, maneuvering terminal phases. This combination works. Expect proliferation of this doctrinal approach among states that have the industrial capacity to execute it. The arms race that follows from this single operational event will not primarily be a race to build more expensive interceptors. It will be a race for new physics, systems that change the fundamental economics of offense versus defense in a way that the current kinetic model simply cannot
Here's what I
achieve.
want you to take away from this. Iran did not win a war. Israel remains a sovereign nation. The United States remains the world's most capable military power by virtually every measurable standard. But one night of sustained ballistic missile saturation proved something that changes strategic calculations on every continent. A determined regional power, through disciplined long-term investment in asymmetric capabilities, can force the most advanced and most expensive defense systems in the world to reach their structural ceiling in a single engagement. That's not a footnote. That's not a talking point. That is a permanent data point that every defense ministry, every alliance planner, and every military strategist on the planet now carries into every future calculation. Deterrence is not a hardware specification. It's a psychological condition, a shared belief that the cost of challenging a military power is prohibitively high. When that belief is tested at scale and the test produces unexpected results, deterrence has to be rebuilt, not just restocked. The smoke has cleared. The interceptor stockpiles are being slowly replenished, the carriers repositioned. But the question that was asked in the darkness at 2:41 a.m. is still being answered in defense ministries and classified planning cells around the world. What do we build next? Whatever the answer looks like, it begins here. Drop a comment. Do you think directed energy weapons actually solve the saturation problem, or does it just shift the advantage back temporarily before the next wave of countermeasures arrives? Subscribe for the next breakdown. This story has chapters still unwritten.